Hello, everyone. Thank you for joining us today for our ALS webinar series. My name is Malia Forbes. I am a marketing coordinator for ALS North America, and I'll be facilitating the webinar today. Before we begin the presentation, I have a few helpful notes. If you are having technical issues with our webinar platform, type your message or question in the chat pod at the bottom right of your screen. You can also select the hand icon to notify me of your status, and I can assist you. All questions regarding the webinar material will be answered at the end of the presentation. Our presenter today is Darlene Stastny. Darlene graduated from Fanshawe College Environmental Technology program in 1992 and has been working in the environmental industry for over 25 years. Her laboratory experience spans waters, soils, and in the last 6 years has come to include tissue and air. Initially working in the lab and progressing to customer service and account management, Darlene is now the ALS Canada technical resource for the air quality testing group. Her early career experience includes 7 years in geriatric healthcare as an RNA, 3 years in the automotive industry as a welder, as well as 2 years in environmental compliance for a medical sciences firm. She is a member of Ontario On-Site Wastewater Association, Ontario Mining Association, an associate member of Air and Waste Management Association, and a certified environmental technologist. Darlene, thank you for taking the time to deliver this presentation. I will now turn it over to you.
Thanks very much, Malia. Welcome, everybody. And without further ado, we'll go right into the presentation. I have a pointer here that you'll see from time to time, and that's just to be able to accentuate some of the items that are on some of the pictures. And so we'll go on. So air canisters are not our only form of air sampling that we have within ALS, but for ALS Waterloo, it is probably one of the primaries. So one of the things that we pride ourselves on is the quality of our canisters, and we do stock 3 different kinds. So the 6-liter Silonite canister, which is the one that probably most people that do any air sampling as far as whole air are familiar with, looks like this one here. And on top of it, you'll see a time-weighted average flow controller. The next one is a 1.4-liter canister. This particular one has gone through a couple of iterations, and so if you order these, you may see some that are either convex or concave on the bottom, and we do provide stands for those if you need them. And they've gone as far as being from cylindrical, some are a little narrower than others. And then last but not least, and certainly not least, is the 1-liter Bottle Vac. Now, just keeping in mind that all of the equipment that we use are EPA approved as far as the US is concerned, but also Canada approved as far as our Canadian clients are concerned. The 1-liter Bottle Vac has the same structure as far as the coating is concerned. So it's also Silonite, and Silonite has the same inert properties that a glass would have, it so that this particular coating, it refracts light. You'll see some of the colors that show up, and it also is an inert material. The 1-liter Bottle Vacs are a great add-on to what we have with the 1.4s and the 6 liters, because they do take something called dirty samples very well, and I will detail that a little bit further on in the presentation. So what can we use these for? The 6-liter canister for sure is used for indoor air. If you're looking at industrial air, you're looking at personal exposure, and you want to be able to take a whole air sample. Whole air, the difference between whole air and another type of air would be if you're using a pump drawing through a tube versus taking an actual whole air into a canister that's under vacuum. Ambient air works also really well, and long-term samples. And so the larger the can, the more sample that you can take, the longer term sample. It does not decide which type of analyses that you can do. So size of canister does not affect the type of testing that you can do. Then you've got your 1-liter Bottle Vac. I talked a little bit before, mentioned that it takes dirty samples. So what do we mean by that? Samples that are high in sulfur, high in any contaminant. And why would we use the 1-liter Bottle Vac for that? A, because it is very cost efficient. If we end up with a sample that's highly contaminated and we can't get the Bottle Vac cleaned, we simply remove the mechanism that's on the top here, and we can recycle this bottle. We don't like to, and there is a charge to do that if we can't get the bottle cleaned, but it is one of the advantages. The other thing is you can see into the bottle. So if you are drawing air or particulate, which shouldn't be, but sometimes does happen, you can actually see that, or any kind of moisture that's getting in here, you can actually see in the bottle. You'd use this for soil vapor probes, for tank head sampling, and I've got an example right beside the bottle vac of a tank head. So literally a solvent tank or a fuel tank that actually has a connection on the top for an air sample, so that you can make sure that any type of gases that are evolving off are still there at safe levels, so that you're not looking at a worst case scenario canister explosion, but also having to evolve off air into the atmosphere that is high in hazardous contaminants. Landfill gases are also great taken into a 1 liter bottle vac. And by landfill, we're talking about things like carbon dioxide, carbon monoxide, methane, oxygen, nitrogen, and short-term samples. So again, as I had said before, the size of the canister affects how long you sample, not what you're sampling for. So short-term samples work really well into a 1 liter bottle vac, and they're very versatile. There is an overlap between the 1 liter and the 1.4 liters. So when you see the 1.4 liter, the first thing that you see obviously is that it is metal. The disadvantage that it would be if we had a dirty sample is we can't see what's in there, and it takes a lot more cleaning. It's much more expensive to replace. It's about 3 times the cost of a 1 liter bottle vac to replace it if we have to. So it really is useful if you have any kind of knowledge of your project to start off with a 1 liter bottle vac, especially if you're doing a diagnostic, or if you haven't looked at a direct reading instrument prior to actually taking the sample, which most of you will have done. Again, you'll notice there is a big overlap. In Western Canada, we have noticed that the preference is for the 1.4 liter bottle, or 1.4 liter Silonite canisters, as opposed to the bottle vacs. They're not as familiar with using them. However, in Ontario, we are seeing a lot of the 1.4 liter, or 1 liters, the 1 liter bottle vacs used for mining projects, for projects where they're just doing a short-term sample. And they are very convenient. The netting on the outside just protects them. They are thicker than a standard 1 liter bottle, so they also don't break as easy. And all of these canisters are evacuated, so they are under vacuum. The sampling process we call it as passivated canister, whole air, and passivated simply means there's no pump required to be attached to them. So I'd hinted a little bit in the last 2 slides about sampling times. So what are my options? If I have a 6 liter canister, I have options of 1, 4, 8, 12, and 24 hours. So these are long-term samples. When would you pick a 24-hour sample? A couple of reasons. If you're doing a couple of times, if you're using a residential as your sampling area, a residential home, you want to know what's happening in that home for the whole 24 hours when you're trying to get an air sample. Even if you were doing a sub-slab sample in a residential home, a 24-hour would be prudent to take. However, if you are looking at a shift for industrial workplace, perhaps an 8-hour or a 4-hour is long enough. If the industrial application is such that every 4 hours is simply the same as the next 4 hours, so the production is consistent for the whole 24 hours, then a 4-hour sample is more than long enough. If it changes over time, yet there are 3 different shifts, then a 24 may be what you want to go to. In an office setting, generally 8 or 12 hours is more than sufficient. So those are some of the reasons that you would take that sample. A 1-hour sample, as you will see, both the 1 liter and the 1.4 liter canister can also do a 1-hour sample. The difference is the time-weighted average flow controller versus a short-term grab sampler. So what our time-weighted average flow controller has, it has a diaphragm in it. And when we calibrate it, we're able to calibrate it quite accurately with that diaphragm. It only fits on the 6 liter, it only goes on the 6 liter canister. It does not go on the 1.4 or the 1 liter. Our 1.4 and 1 liter canisters use a grab sampler, and I'll show you a picture of that a little bit later on. I had shown it to you in a previous picture, but there's another one coming up. The short-term grab sampler has a flow restrictor in it, and the flow restrictor is the part that we take out and replace when you let us know how long of a sample that you're taking. So whether it's, and that's why we call it grab, it's a quick sample, 4 minutes, 10 minutes, 20 minutes, 60 minutes. So there is just the flow restrictor. There is no diaphragm in that particular flow controller. What we do is we take all of the grab samplers completely apart when they come back, and everything is thermally cleaned. So our process must include thermally cleaning everything to make sure that it is contaminant free. And these processes take a long time. We can be cleaning the components for the grab samplers for up to 5 days in an oven to make sure that it is contaminant free, and we build the flow controllers every single time. This also goes into the time component that we ask for when we need some lead time in preparing your order. So it's really important to give us as much notice as you can so that we can ensure that we can build what you need with the best possible equipment. Most people, when they talk about canisters, will refer to Summa. As a matter of fact, if I look in some of the regulation documents for Canada and even for Ontario specifically, we will see Summa written right in there. What does Summa refer to? Summa refers to a particular product. So similar, and a good analogy would be Kleenex is a tissue. Summa is a type of canister. It's a coating that is put on the inside of the canister, and really what they've done is they've electro-polished the inside. There is no additional Silonite, just like what we do in our Silonite canisters or another type of coating. The inside is polished. What happens over time is compounds such as sulfur eat at the metal on the inside. And again, you can't see the inside of the can. So while we continuously clean them and proof them, we can develop something called active sites or pits that is exaggerating. I mean, it would be hard to see these because they're quite small, but a pit would develop, and that's where we would have different contaminants would stick to that. What Summa came up with when they were developing these Summa canisters is they would simply inject a little bit of water on the inside, swish it around, and that would coat the walls, so there to prevent active sites. The Silonite coating doesn't have that. It is inert, and we do proof these canisters every time. What does happen over time is those outside layers the coating layers do wear. And so there is an opportunity to send these back to our manufacturer, in this case, Entech, and they would then recoat that inside. And that would be if our canisters no longer can pass any type of proofing. So that really is the biggest difference. Both are accepted in the market. The EPA and Canadian regulations approve of both. Again, Summa refers to the electropolished inside, whereas Silonite is a more updated product with the coating that then remains inert, and it is hydrophobic, so it does not like water. This brings us to cleaning. So again, I mentioned a little bit about that in some of the previous slides. We will often ask our clients 3 questions when they place an order. What type of air are you sampling? How long are you sampling? And what criteria you're looking to meet? And why do we ask about the criteria? We ask about the criteria because that determines the level of cleaning that needs to be done. First thought that would come to some people's mind is, well, why don't you just clean everything to the lowest level? That would make sure that you could use it for everything. Well, that would be great, except that you're dealing with a mechanical item. And if you clean everything to the lowest level and you get a highly contaminated sample inside, now that ultra low level clean can, even though we've cleaned it and cleaned it and cleaned it, can never be cleaned to the level where it could be used on ultra low level. And eventually all of your low level clean cans move to regular level and you deplete your low level ultra proofed cans. So it really is important for us to know if there's not a particular criteria that you're looking to meet, if you are targeting a particular compound at a particular level. We have various packages available, and we can certainly always go through and send you some of the options that you have so that you can have a look. If you're looking for chlorine degradation compounds and you're looking inside a closed space, maybe you want low level. But if you're looking outside in an ambient air condition, perhaps just regular levels just to see if anything is evolving off is important. So trying to narrow down what type of cleaning really does, A, help maintain our ultra low level clean cans so that we can do things like health-based indoor air, or reach risk levels, or provide you with individual proofing. Every canister that we clean that goes through our system is proofed individually. Just to give you some information with respect to that, we report batch level unless there's a specific request for individual proofing, which we charge $100 for if you want the individual proof for that can. The batch proofing is 1 in 20, and it simply indicates that this has gone through the entire system. However, in order to maintain a record of every single canister, we must proof the cans. And this is how we are able to determine if there is any kind of trace level below reporting limits of any particular compound. So that when you get your results back and you feel there may be an anomaly, we can actually go back and look at the information on that canister and tell whether that particular compound that is of concern has been in there at any kind of trace levels. That way, putting your mind at ease and providing a certified document reporting with the report that shows that we've actually gone back and looked at this. So it really is important for us, again, to know what type of cleaning level it is that you are looking for. All of our canisters, so the ones that I showed you, all have serial numbers. Those serial numbers are recorded, and that's how we maintain the history on our canisters. So I've got a question at the bottom because this does come up. What if I want to change my analysis from my original request? This is where that serial number that is on your canister comes into play. First thing that you need to do is give us a call and say, I want to change, got on site. I had originally asked for chlorine degradation compounds, but oh my goodness, all I can smell here is xylenes. Can we please do a full TO15 list, which will include xylenes? What our next course of action is we will take that serial number, we will go back to the history on your particular canister, and we will come back with a yay or nay. So knowing in advance is important, extremely important. But if you have to change, it has to be prior to you taking the sample, because otherwise we may not be able to guarantee that that wasn't a contaminant below reporting limits in that particular can. So please, if you have to change, always contact myself or the air quality group and ask them and always have your serial number for your canister in hand. All of our equipment is outfitted with Nupro valves. So quick connects, and if you look at this is the female end of the quick connect, and this would be the male end of the quick connect, are revolutionary in the air sampling industry. They're wonderful in cold weather conditions because you're not worried about trying to tighten nuts or bolts or overcranking or metal bending. And these were developed by NASA for that specific reason, but also because you don't require additional equipment on hand when you're trying to connect them. So we use them. This is a duplicate sampler. And so as you can see, it's in the shape of a T, but when you're connecting your canisters to it, and you'll see that in the next picture, the canisters are connected first and allowed to equilibrate. So the connection between this end and this end, once the canisters are connected to it, is fluid. So they are connected and they equilibrate. Once they've had a chance to equilibrate, and this takes a very short time, then you can add your flow controller to the top. So in this case, it's a time-weighted average flow controller. There's the diaphragm. And if you can actually see the tubing that goes off of there. When we get a little bit further, I will also show you the swage lock fittings that do go onto the end of the flow controller so that you can have an idea of what the nuts and ferrules look like. But this is a typical setup for a duplicate sample when you're doing soil vapor. If you're doing 6-liter canister, indoor air or ambient air, quite often the canisters are co-located, and this is permitted by regulation to stand them side by side so that you can start the sampling at the same time. There is a valve there that you can see, so you put your flow controller on the top, and then if they're side by side, you simply open the valve simultaneously. However, that being said, you can attach this duplicate T sampler to the 6-liter canisters on their side, lay them on their sides, and attach a flow controller to the top, and take a simultaneous true duplicate sample if you choose. The 1-liter bottle vacs are also equipped with the Nupro, or with the Quick Connect Nupro valves. And if you look at soil vapor probes, there's a number of soil vapor probes that are out there now, and there's a direct Quick Connect, and so they require the female Quick Connect fitting to that, and we do provide that. So just a heads up that if you need a female end so that you can connect directly to your soil vapor probe, we can do that. We just need to know that in advance. So what additional equipment can we provide? The canister stand in this small picture, and it was in the previous picture as well, can help stabilize a 1.4-liter canister. Is it mandatory? With our new canisters, they actually have a concave bottom, so they stand quite well on their own. However, if you have one that still has the rounded end, either the canister stand or a boot is useful. For the 6-liter canisters, they're quite stable on their own. They don't fall. You know, they have a quite solid round base. It's almost like a cage that sits around them. So they're usually pretty stable. As I had mentioned before, this is our duplicate sampler, so that is something that you can order through us. And as you can see, it is also put together, made of Quick Connect, but also Silonite coated. So you can see the colors on it, which means we thermally clean that as well. There is there is a rental charge for this. We do provide the duplicate samplers, but we do provide them based on a rental cost. So here's the Teflon tubing with the swage lock fitting, the nuts and ferrules. So you can see the ferrules here on the nut on the outside, and that is what you connect to the end of your flow controller. I'm just going to go back to here. So you would connect that to the end here and give it about a quarter turn to tighten. So not more than that, because if you over tighten, these little ferrules will bend, and that's what they're designed to do, onto the tubing. But if you tighten too much, they'll warp and they could possibly puncture the Teflon tubing. So again, they need to be tight, more than finger tight when you attach them to the flow controller, but just give them about a quarter of a turn. Last but not least is our soil valve adapter. We've come back to build this because there has been some protocol that was written into certain standard operating procedures for Ministry of the Environment programs that required these particular valves be present on our 1.4-liter cans. So I'm just going to, and I apologize for flipping back, but I want to show you. So our 1.4-liter cans and our 1-liter bottle vacs do not have valves on them. So that means as soon as you connect your flow controller to the top, you're sampling. So you would attach any type of sampling train that you have onto the end of your flow controller with the nut and ferrule and the Teflon tubing, and then get it all ready. And as soon as you're ready to sample, you attach to the flow controller. The same as soon as you disconnect your flow controller from the top of the bottle, you stop sampling. So the valve literally seals off the second it's disconnected, starts to sample as soon as it is connected. These particular items can be used on top of the 1.4-liter or the 1-liters in case you do have to have that TOV valve present when you're doing your sampling protocol. It isn't required in order to do a regular sample, but if it is part of your standard operating procedure, we do have them built. The disadvantage of these particular items is they add to your dead air volume and could contribute to contamination. So you're adding an extra piece to the top of your canister, so you could be contributing to the dead air volume. Independent vacuum gauges are included in every order. Tedlar bags, we strongly discourage clients taking samples in Tedlar bags for any type of air work that is coming to us, because Tedlar bags are porous and are prone to collapse, and because the hold time on them is only about 24 hours for things like sulfurs, a little longer for fixed gases, so that's the landfill gases I had mentioned earlier, your carbon dioxide, methane, oxygen, nitrogen. They really are not a stable item to use, and when people use them for a cost savings, just keeping in mind that they are only $22 if you buy them from us. However, there's a $75 charge to transfer that into a canister so that then we can extend the hold time and make sure that we get the best possible data, or if we have to go back to the canister to draw another sample, that we can actually do that. So when we charge $95 for canister rental and you're paying $97 to take a Tedlar bag, which doesn't guarantee you a great sample by the time the transfer price is added, by the way, there really isn't a cost savings for a Tedlar bag. So it really is important to use the best possible equipment. Again, cost is a huge thing. If you're paying $315, which is the TO15 list price for a Canadian price for our VOCs, the last thing you want to do is have a lost sample and have to go back and take another sample again, or us having to come back to you and say, look, the Tedlar bag is partially deflated. We can't draw a sample out of there, but we can't guarantee the concentration is going to be accurate. So it's really important to take the time to use the best possible equipment when taking a sample. As I'd mentioned in the previous slide, hold time does play a huge role when you are sampling. So when you're trying to take a proper sample, and I apologize for how small this particular diagram is, but take some time to go back and have a look at it, or print it off, use it as a reference. It gives you an idea of what the hold times are for various particular items. If you go back and look in the notes here, so for sulfur, 24 hours in a Tedlar bag. For fixed gases, 72 hours. It really does not benefit if you to take it into a Tedlar bag. I know they're convenient, but if we can't get the sample within the hold time, now you're going to even be charged for rush samples. So where it can be avoided is best done. We do provide the Tedlar bags for siloxanes because you're going to draw out of that Tedlar bag and deposit it onto a thermal desorption tube on site. Ordering in advance is really important. The more time that you can give us, the better it is. We always like to have a week. That allows us to get the sample media ready, so your canisters and your flow controllers ready. And we do include, by the way, our flow controllers with our canisters. So the canister rental cost for $95 for a regular level proofed includes your flow controller. It also, the 1 week allows us to provide the ground shipping to most locations, keeping in mind that if you are a remote location, it can take up to 8 business days to actually get the material to you. So that also has to be taken into consideration. If you have 2 weeks notice when you're looking at some of these type of projects, please give us that so that we can get the order ready and make sure that we have it. We have rarely had to turn away last minute requests for our equipment, but it really is important to give us as much notice as you can and to get the equipment back to us in 2 weeks. Our rental time is 2 weeks, and after that we do start looking at charging additional rental fees. We've tried to be a little bit lenient on this, and we literally have hundreds of canisters of each size in stock. But when canisters are held for a particular amount of time that extends that 2 weeks, then we can't get them ready for another project, for another client, and sometimes for your company. Somebody else within your company is looking for canisters, and we have to delay their order because we're waiting for things to be returned. So the more efficient that they can be returned as far as time is concerned, the better it is. Choosing canister size, we discussed again when we looked at the sampling times. The type of analysis is not affected by the canister size, but the length of sampling time is. One thing that we always encourage is that if you are doing sulfur analysis and fixed gases, that you take 2 cans. And the reason for that being is one of the compounds that we analyze for in our fixed gases is nitrogen. But we pressurize the cans with nitrogen to do the fixed gases. Sulfur has the shorter hold time. So we have to do, in theory, we would like to do the sulfur first. If we have a fixed gases request, we have to do that first, but we still only have 7 days from sampling, which is still the hold time in canisters, to get the sulfur analysis done. I hope I haven't been too confusing with that explanation, but it really is important to be aware that if you were doing fixed gases and sulfur at the same time, take an extra can. Oh, sorry. One item I wanted to go back to, ground versus express shipping. So ground shipping is at our cost. We don't charge for this. And we can let you know if you're trying to set up your program how long it's going to take to you by ground shipping. If you are wanting an order fairly quickly so that ground shipping isn't an option anymore, we do charge for express shipping. And to give you an example, it probably starts about $140 for one large cooler of canisters, which we can fit about 5 of the 1.4 liters and only 2 of the 6-liter canisters in. So just to give you an idea of approximate cost, that's what you would be looking at. So that brings us to canisters do's and don'ts. And one of the things that we always encourage our clients to do is when you get your order, take that independent vacuum gauge and check the vacuum on the canister. It needs to be ideally between minus 28 and minus 30, but between minus 25 and minus 30 is great. Take a record of that, note that down. When you start to sample, please, again, check the vacuum. It's really important to make sure it's under vacuum. It's also important to note that when you're taking an air sample, not always is the air coming in at a regular flow rate. Even though you're drawing it in with a flow controller, if you're dealing with an area of negative or positive pressure, the canister will fill up faster or slower than perhaps what you anticipated. So short-term samples, always check halfway through your sampling time to see how fast your canister is filling. So look at the vacuum gauge. There is one installed on the flow controllers, whether it's a TWA flow controller or a grab. There actually is a vacuum gauge on there too. Check to see how fast your canister is filling. If it's filling faster than what the anticipated time is, then you may not need to sample as long. Sampling or filling till between minus 5 and minus 8 inches of mercury is the most important, and you would simply record your sampling time based on that. Connecting the swage lock fittings, again, I had mentioned that earlier. Some of the downfalls are when you take your wrench to connect it on there, it needs to be tight, more than finger tight, but not cranked so hard that it's going to either strip the screw up or strip the bolt, the nut itself, or strip the end of the flow controller. So it just needs to be on there tight. Canisters need to be kept dry, away from extreme heat and cold. When you're talking about extreme cold, minus 15, minus 20, we've seen canisters go through as long as they've been sheltered, so they can't be just sitting out in the open. As far as extreme heat, 30 degrees C isn't unusual. Again, if there's a way of protecting your canister from extreme weather, it's really important. Do not put ice in the cooler with the canisters when you're shipping back. We bring the canisters up to room temperature to use them and start prepping them for analysis. So please do not put ice in with them. As I had said before, the Silonite coating is hydrophobic, does not want water near it. So please do not put ice in with it, or they don't require refrigeration. The other thing that we ask you to be aware of is, other than tightening the nuts and ferrules onto the end of your flow controller, please do not use the wrenches on any other part of the canister or flow controller. If you have any concerns about it being loose, by all means, give us a call. My cell phone number will be at the end of this presentation. There is contact information on the paperwork that comes with your order. Always give us a call if something seems loose, and one of our technicians or the lab department manager will give you direction on what to do or how to tighten things up if they need to be tightened. Keeping in mind that when it comes to quick connects, there is some play and there is some movement in those, and that's intentional. That allows for expansion and contraction of metal without it bending, and making sure that your equipment works and functions properly. And finally, there's a few other options that you have when you are sampling for air, and I wanted to let you know that we do provide these as well. Thermal absorption tubes, either active or passive sampling, are some of the options that you may have. Tedlar bags, as we had discussed before, in certain applications. So for example, when you're sampling for siloxanes. And then there's also IH methods. Some of the industrial hygiene methods, we usually preface them with either NIOSH, NMAM, or OSHA, are well provisioned to work for your particular sampling project. And not every single compound can be sampled or analyzed out of whole air. A classic example that we sometimes get is formaldehyde and ammonia. They have to be sampled onto a different media. We can't put those in canisters. So letting us know what your sampling program is about, and we can give you some direction as to what equipment we have that might be able to be utilized for this. And we're happy to do that. Again, you can contact myself, you can contact one of your account manager, and either your account manager, if they have the knowledge, will give you the information, or they'll direct their questions to myself or to one of our labs that do some of the other air testing as well. I wanted to really thank you for all of your time, and I really appreciate that you took the time to go through the presentation and listen to what we have to provide as a company when it comes to whole air sampling with canisters. Thank you.
Thank you, Darlene. We will now open up the forum for questions. Please write out your question in the chat section at the bottom right, and I will give everyone a few moments to do that. I see we do have some questions coming in. I'm going to go over some brief notes while we wait for more questions. This webinar presentation is being recorded. All participants of this webinar will receive a follow-up email once the recording is available for viewing. We also post our webinars on our ALS Global website and our ALS YouTube channel in the webinar playlist. I encourage you to find a wide range of video resources and past Webinar Wednesday presentations available there. Also, please follow our showcase page on LinkedIn as we post announcements and registration links to future webinars and other valuable resources and updates. Okay, Darlene, David Cantor has a question. Hi, Darlene. Thanks for the informative presentation. My question relates to sampling with canisters versus thermal desorption tubes. From your experience, is one of these methods superior for soil vapor sampling?
That's a great question. So they aren't superior as much. There isn't one method superior to another as much as different. Thermal desorption tubes work great when you have an idea of what concentrations you are looking for and which VOCs you are looking to target. Our thermal desorption tube TO14, or its method is TO17, but the TO14 list is substantially smaller than what our air canister list TO15 is. So that often has an effect on looking at the results. That being said, we can target lower reporting limits on our thermal desorption tube than what we can with a canister. So it really has to be a evaluation of what is the information that you are looking to try and get from the sampling program in order to decide whether canister or tube is a better method. One gives lower reporting limits, one gives larger list of analyses. The other thing is with a thermal desorption tube, the recollect feature on the thermal desorption tube, which would allow us to go back and do an analysis, doesn't have a great recovery. The thermal desorption tube itself, greater than 90%. Canisters, we can go back and take another air sample out of that canister if we have to. The recoveries on it, greater than 85, 90%. Again, the recoveries on it are fantastic. I would say when we thermally strip the tube, thermal desorption tube, we do get a little bit better recovery. So if you are targeting one of the VOCs that it's good at, it works great.
Thanks,
Does that
Darlene.
answer your question?
We have another question from John. What happens if we exceed 30 centigrade? It's hard to meet this in Texas for soil gas.
I think the most important thing is to make sure that the canisters aren't sitting in direct sun and sitting sheltered. So 30 degrees Celsius is what we try to stick to. I know that we are sampling in the middle of July when our heat factor here, although it says 36 or 37, we're well above 40 as well. So keeping the canisters sheltered, trying to keep something to keep them protected is best. Keeping in mind that when you've got taking a sample, even soil vapor, the air that's coming in there is usually a little bit cooler, and that will help. There isn't a perfect solution for this other than saying that, when you're taking a sample, in heat, your air dissipates quicker, you have a bigger chance of leaks too in your sampling train. So it's always trying to find that perfect balance as to when it is okay to sample. But soil vapor generally has not been a problem, even in super hot conditions.
Our next question is from Mohammed. He said, what is the suitable final canister pressure?
The suitable final canister pressure would be between -5 and -8 inches of mercury on your vacuum gauge. And the reason that we ask for there to be some pressure left in there is because once you get to ambient, our flow rates that are set with the flow controllers are meant to be under vacuum. Once you are at ambient, not ambient, once you're at atmospheric, I apologize, you are no longer drawing a sample in under vacuum, and so we can't guarantee the flow rates. So that's why it's important to stay between -5 and -8. And if you are taking samples in a situation where they are cold, we will bring the canister up to temperature, up to room temperature before we start to do analysis on it. And so then air expands with heat. And so it will come up a little bit when we get into the lab. And we do take another pressure reading when we get it into the lab.
Jarrett asks, what leak detection method do you recommend? I'm thinking specifically about the helium shroud.
So helium shrouds are pretty conventional. That's what most people use in the industry for canisters, whether it's the 1 liters, the 1.4s, or the 6. And while I can't tell you that one particular leak detection method is better than another, it really depends on your particular project, where you're taking a sample. Again, helium dissipates very quickly if it's very hot out. So if you're trying to do leak detection, sometimes helium isn't the best choice when you're dealing with very hot circumstances. But it is generally the rule of thumb. And we do have a helium leak detection one-pager that if you ever would like it, it's actually more than about 1 page, but we can certainly forward that to you, and it gives you an idea of using our canisters with the quick connects and doing the helium leak detection.
Thank you so much, Darlene. I have one more question from Jarek. Hello, Darlene. Could you discuss vacuum pressure measurements prior to sample collection at elevations? Is 25 in Hg acceptable? Thank you.
Absolutely, it is. Recording your elevation or where you are is always useful. That way, if there is any particular question when we receive the canister back in the lab in Waterloo, we can take that into account. And if Andrea, who is the lab department manager there, has any question with respect to the elevation that samples were taken at, for example, we do have clients that are in Alberta that are going up into higher elevations to take samples. She will contact you to ask any additional questions that might be required.
John asks, what is your suggestion in case of pressure exceeding -5 to -8 Hg, even after the sampling time has passed? For example, we are seeing final pressure of -20.
When you're drawing on, generally, if you're drawing on something that has a negative pressure, it's going to take much longer for the sample to get into the canister. And if it's drawing against a negative pressure, no matter what that vacuum is in that canister, it may not be able to draw hard enough against that negative pressure. So there's a couple of options. You can either take a longer term sample. So continuing to take a sample past the sampling time. If there's a way of reading a flow rate on your sample or what's coming into your sample environment, if this is a soil vapor sample, that would also be useful. But the more sample that we can get into the canister, the better. We can still do the analysis if we are getting a canister reading of -20. What we are doing with that sample when we get it in is we pressurize with nitrogen. So we would have to add more nitrogen, so your dilution is going to be larger. So the effect on a sample that comes in well below the amount of sample that needs to be in that canister is that we would have to do a larger dilution. It's not impossible to do the analysis. If there's any way of taking a longer sample, that would be advisable.
Mohammed has a follow-up question. What is the acceptable gas humidity?
We don't like to have anything above 80% relative humidity. We'd prefer not to have that much, but what we will do, because when we do pressurize the canisters, we pressurize with dry nitrogen. If we have an extremely humid environment, or if the sample seems quite quote unquote wet, we will add wet nitrogen or moist nitrogen into the sample so that we aren't altering the relative humidity that is in the actual canister.
Thank you. I'd like to thank all of our attendees today, and thank you, Darlene. Again, this webinar recording will be posted, and everyone have a great rest of your day. Thank you.